Welcome back to Concepts in Arithmetic. In this video we are going to go over some material about subtraction. In particular, we're going to pay special attention to the various interpretations of subtraction that you can use. So subtraction is defined in terms of finding the missing addend. So, for example, 13 minus 8, that is the number that fills in this blank right here. So 8 plus blank equals 13. So the number that we can use to fill in that blank right there, that's what 13 minus 8 is. Now, in your teacher manuals, you might see this bit of vocabulary here. So when we're dealing with addition, you have, of course, two kind of input numbers to the addition process, and then you have the output. The output is called the sum, and the inputs are called the addends or summands. Okay, so 13 and 26 are the addends, and this is the sum. When you're dealing with subtraction, it's a little bit different. So let's reverse that problem. So 39 minus 26 equals 13. Okay, this over here, the result of our subtraction, that's called the difference. Now, these guys, they have different names. This is called the minuend, and this is called the subtrahend. Okay, so that's the number being subtracted. And the reason they have to have different names is, of course, that order matters. Okay, 39 minus 26 is 13, but if you switch them, well, you've got a different problem there. Okay, so these two have to have different names. All right, so let's get into some interpretations. So ways to think about the operation of subtraction. So one of the ways to think about it is this part-whole interpretation of subtraction. Okay, so for example, there are, let's say 29 let's make it children. I was going to say people, but there are 29 children in the class, and okay, let's do this here. Let's say there are 11 boys. How many girls in the class? Okay, so we have the part, 11 boys, and then we have the whole class, which is 29. Okay, so to answer this question, we would certainly need to do a subtraction. All right, and you can illustrate this quite nicely with a bar diagram here. We know how big the whole class is. Okay, and we know how many girls there are, or sorry, we know how many boys there are. So we know the total length of this bar is 29, and we know there are 11 boys, so the question we're trying to answer is, how big is that piece? Okay, so it's a neat way to illustrate that with the measurement model. Okay, of course we could illustrate this with the set model as well. We draw a big set with 29 little X's in it, and then we could mark off 11 of them and then count up how many would be in the other portion. Okay, so this really highlights that missing addend definition that we just discussed. Okay, so basically we're saying 11 plus blank equals 29 right in this model, and that is illustrating it right there. Okay, another important way to think about subtraction is the takeaway model. Okay, let's make it something like this. We'll say Ralph has 12 eggs. He uses 3 for his brownie recipe. How many are left? Question mark. All right, so could very easily indicate this with a set model. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have 12 there. We take away 3. And we see that there are 9 left. Okay, so a couple of things that I would point out here. I would note that right over here, this part whole model is very conducive to a count up strategy to find the difference. And what I mean when I say a count up strategy is, okay, let's say we tell our students there are 29 children in the class and there are 11 boys. How many girls? Well, we start with 11 and then we can count up until we get to 29. And by paying attention to how many we have to count, that can give us our answer. This takeaway model lends itself to a count down strategy. Okay, so we start with 12 and then we count down 3. Okay, so 12, 11, 10, 9. Okay, so we count down there. And of course you can also use the measurement model to help you with your takeaway interpretation here. You can work it out on a number line. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you start with 12 and you count down 1, 2, 3, and you have just what we discussed. Oh, it'd help if I actually counted correctly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Huh. So 1, 2, and 3 to illustrate the answer to our little word problem over there. And the last interpretation I want to talk about is the comparison model. So let's say the problem is something like this. Alice uses a 14-pound bowling ball. Bill uses an 11-pound ball. how much heavier is Alice's ball? Question mark. Okay. So the model I might use for this, actually it involves two bars here. We'll have one bar for Alice's ball, which we know is 14 pounds. So that's the one for Alice. And then we might have a bar for Bill. And let me get out of the way here. So this is the bar that represents Alice's ball. This is the bar that represents Bill's. It's 11, so what we're trying to do is we're trying to find out that length right there. So we're comparing the two lengths and trying to figure out the difference to get our answer. Okay, so just a couple of different interpretations for subtraction. I'm going to go ahead and come back. Maybe I'll scoot over here. Okay, so a couple of different interpretations. So you have the part-whole model. Once again, conducive to the count-up strategy. We have 11 boys in the class, and then we count up. And it really highlights the missing add-end property. You have the takeaway interpretation, and you also have the comparison interpretation. And I'm just going to get out of the way entirely so we can actually read this. Okay, so those are our three interpretations of subtraction.